Assalamualaikum. My name is Norvaiza Putri Octavia binti M. Sukir and my matrix number is A23A2236. We are from Group 3 and today we will be presenting our assignment on the application of mathematics and statistics in business using life insurance charge data. Statistical analysis help business collect, organize and interpret data to make informed decisions, identify trends and assess risks. The dataset used in this assignment consists of 1,338 observations and includes variables such as age, gender, BMI, number of children, smoking status, region, and insurance charges. These variables are classified as either numerical or categorical variables. By analyzing them, insurance company can better understand the factors that influence insurance charges, improve pricing strategies, and evaluate risk levels. To achieve this, we apply statistical methods such as sampling, descriptive statistics, graphical analysis, hypothesis testing, independent sample t-test, and ANOVA. Through the assignment, we aim to demonstrate the practical application of statistics in business decision-making.
My name is Siti Hazikah Izalia binti Nuzairi. My matrix number A23A2190.
In this section, I will explain how our group selected the data sample for this study. First, we extracted the last two digits from each group member's matric number. The digits we obtained were 17, 24, 30, 36, 47, 62, 72, 84, 90, and 92. Next, we identified the smallest number, which is 17, and the largest, which is 92. Using the formula, we calculated 500 minus 17, giving us 483, and 500 plus 92, giving us 592. This means we will be selecting 483 cases from the first 592 records in the dataset. For step 3, we use IBM SPSS statistics to randomly select the cases. We open the data menu, choose select cases, then selected the random sample option. We enter exactly 483 cases from the first 592, choose to delete the unselected cases and click OK.
Assalamualaikum and good day everyone. My name is Dah Hatiza binti Muhammad Azlan. I am matric A23A1762. I will be presenting step 4 and step 5 of our sampling and data selection process. For this study, we use simple random sampling, which is a probability sampling method where every record in the population has an equal chance of being selected. This method helps to reduce bias and ensure that the sample is representative of the population. Based on our calculation, 483 cases were randomly selected from 592 cases for further analysis. The selected sample contained both quantitative variables such as age, BMI, charge, and number of children, as well as categorical variables including gender, smoker status, and region. After the sample was selected, the new dataset was saved for further statistical analysis in SPSS. This was done by selecting file, then save as and saving the filtered dataset as a new file. This ensures that the sample data can be used for descriptive and inferential statistical analysis without affecting the original dataset.
Hi, my name is Ainus Raya binti Muhammad Ardi. My matric number is A231692. The next part is descriptive statistics. A descriptive analysis was conducted on 483 respondents. The average age was 39.22 years, while the mean BMI was 30.60. Insurance charge showed the highest ratio with an average of 12,967.42. The sample consisted of 50.9% female and 49.1% male. Most respondents had no children and were non-smokers. The respondents were also very evenly distributed across the 4 regions. Overall, the data show a balanced distribution of respondents by gender and region, while insurance charge had the greatest variability. The result provide a general overview of the respondent characteristics.
Assalamualaikum and good day everyone. My name is Muhammad Razim bin Mat Zaid. My matric number A23A2217. Okay, today I will present about 3.2, which is a graphical representation. For section 3.2, graphical representation were used to visualize the data and make the finding easier to understand. First, the pie chart show that the gender distribution is balanced, with 50.9% female respondent and 49.1% male respondent. The result also indicate that the majority of respondents have no children or only a small number of children. In addition, 81.4% of the respondents are non-smoker, while only a small percentage are smoker. The respondents are also fairly evenly distributed across all regions, indication good representation of the sample. Next, for the continuous variable, the histogram show that both BMI and age are approximately normally distributed, meaning that most respondents are concentrated around the average values. However, the distribution of insurance charge is positively skewed, where most respondents have low to moderate charge, while a small number of respondents have exceptionally high charge. In conclusion, the sample is well distributed across demographic categories, while insurance charge show the greatest variability compared to the other variability.
Assalamualaikum and hi, my name is Nick Zaris Aidil bin Arlin Nadrin and my metric number is A23B1424. Put this into practice using software like Spss, we ran two different analyses. For our first test, we wanted to see if having children changes what you pay for annual insurance. Since we are comparing exactly two groups, people with no children versus people with at least one child, we use an independent sample t-test. This allows us to compare the average cost between these two distinct groups to see if parenthood status makes a statistically significant difference. Finally, we wanted to see if geography plays a role in life insurance pricing. Because we are looking at four different groups this time, Northeast, Northwest, Southeast, and Southwest, the simple t-test won't work. Instead, we scale up to an ANOVA, or analysis of variance. This test allows us to compare three or more groups simultaneously, helping us determine if insurance companies alter their pricing model based on the specific region an insured person lives in.
Assalamualaikum, my name is Ahmad Arif bin Muhammad Zuli, nomor metrik A23A2230. I will present the independent sample t-test was conducted to compare the mean insurance charge between the respondent with the 4 and 5 children. The result show that the mean insurance charge for the respondent with the 4 children was higher than those with the 5 children. However, the p-value of 0.133 was greater than 0.05, indicating that the difference was not statistically significant. Therefore, we failed to reject the new hypothesis and conclude that there is not significant difference in insurance charge between the two groups.
My name is Muhammad Amirul Haikal bin Amin. My metric number is A23A1384. I will explain the use of one-way ANOVA in this study. The purpose of this analysis is to compare the average medical charges among policyholders from 4 different regions, which are Northeast, Northwest, Southeast and Southwest. We use one-way ANOVA because it is suitable for comparing the mean value of 3 or more independent groups. Compared to using multiple t-tests, ANOVA help reduce the risk of type 1 error, which means falsely detecting a difference when there is actually none. In this analysis, the dependent variable is medical charges because it is continuous numerical data, while the independent variable is region because it consists of 4 categorical groups. The null hypothesis states that there is no significant difference in mean medical charges across all regions, while the alternative hypothesis states that at least one region has a significant different mean medical charge. Based on the descriptive analysis, the Southeast region recorded the highest average medical charges at RM13,236.63, while the Northwest region recorded the lowest average at RM12,666.24. However, the differences between the regions are relatively small overall. Before conducting ANOVA, Leibniz test was used to check the homogeneity of variances assumption. The significant value obtained was 0.551, which is greater than 0.05. Therefore, the assumption of equal variances is satisfied. and the ANOVA test can be immediately conducted. In conclusion, there are slightly differences in medical charges across the region, but further ANOVA results are needed to determine whether these differences are statistically significant.
And my metric number is A2382047.
Next, I will explain the ANOVA table. The ANOVA results show that the between group sum of square is 2,047,737.572, while the within group sum of square is 68,330,000,000. This indicates that the variation in insurance charge within each region is much greater than the variation between regions. The F statistic obtained is 0.048, which is very close to 0. This suggests that the difference in mean insurance charge among the 4 regions are extremely small. In addition, the P value is 0.986, which is higher than the significant level of 0.05. Therefore, there is no statistical evidence to suggest a significant difference in insurance charge among the region. And based on the one-way ANOVA analysis, the F value is 0.048 and the P value is 0.986. Since the P value is greater than 0.05, we fail to reject the null hypothesis. This means that the average insurance charge across the Northeast, Northwest, Southeast and also Southwest regions are not significantly different, although there are slight difference in the average charge. These differences are too small to be considered statistically significant. Therefore, a region does not appear to influence insurance. Next is pulse hoc Tukey. To further examine the difference between regions, the Tukey HSD pulse hoc test was conducted. This test compares every pair of regions to determine whether any specific group differs significantly from another. The results show that all pairwise comparison have p value greater than 0.05. This means that no region has significantly higher or lower insurance charge than the others. Therefore, the average insurance charge are relatively similar across all 4 regions. Next is the homogeneous subset analysis. This analysis group region with similar mean insurance charge. The results show that all 4 regions are classified within the same homogeneous subset. This indicates that the average insurance charge for 4 regions are statistically similar. Furthermore, the significant value is 0.983, which is greater than 0.05. Therefore, there is no significant difference between the regional mean insurance charge. In conclusion, the one-way ANOVA test produced a p-value of 0.986, which is higher than the significant level of 0.05. Therefore, we fail to reject the null hypothesis. This means that there is insufficient evidence to conclude that the insurance charge differs significantly among the 4 regions. The Tukey HSD and homogeneous subset analysis further support this finding by showing that all regions have similar average.
My name is Nur Aiman Shakir bin Shamsuddin and my metric number is A23B1372. To wrap up our presentations, let's look at the core conclusion of our projects on life insurance charge analysis. Our primary objective was to investigate the structural factors impacting annual premium rates using a sample of 483 respondents processed via IBM Spss. From a descriptive standpoint, our sample shows an even distribution across gender and geography regions. However, the premium charges themselves exhibited massive variability, ranging from just over 1,137 ringgit to nearly 64,000 ringgit, with an average premium of roughly 12,967 ringgit. When we look deeper using inferential statistics, our independent sample t-test showed that having 4 versus 5 dependent children did not statistically alter premium cost, as the p-value was greater than 0.05. Similarly, our one-way ANOVA across 4 geographic regions yielded a p-value of 0.986, proving that location has no significant impact on pricing. This confirms a uniform premium architectural framework across regions. Ultimately, these findings highlight that while certain demographics like location do not shift pricing, robust data analytics remain absolutely vital. It empowers insurance firms to optimize their predictive risk models, maintain a standardized regional pricing structures, and precisely target key lifestyle segments. That's all for us. Thank you very much.